Oh, sorry guys, like the mic was off, it seems. Okay, now you are able to hear me. Yes. So the thing is, yeah, I welcome you guys to NEET World Institute, right? Yeah, whatever I have told now, I will tell again. Okay, no issues. So in this session now, we are going to particularly concentrate on the topic of kinematics. Yes, physics, right? So under kinematics, we have seen some topics like straight lines, right? And straight lines has been completed and the plane is going on. In plane, we are concentrating on the topic relative motion in this session. The projectile motion has been completed and one more projectile motion is there, like from the height h. Okay, that one we will see. So after the completion of the relative motion and the projectile motion from the height h, now we will discuss a few problems in both the relative motion as well as the topics which we have completed in the previous sessions or classes. Okay, that's the thing. Yeah, we'll wait for 1 minute, 1 or 2 minutes. Okay, since students are joining now, we'll wait for the. Yes. I hope the problems which we have discussed in the last class you have completed, right? The homework which I have given also, right? Okay, so let me check the problems whichever you have completed. Okay, and students know, like whoever watching in online, you also can give answers in the comment boxes. Okay, since like here the peoples are present in offline now, so I can watch physically whatever they are doing, right? But the thing, whatever you are doing from home, no, like the people who are watching in online, na, you can give answer in the comment boxes so that we can able to check cross check the answers. And if you are having any doubts also, you can drop a comment in the comment section so that we will we will come, we'll come to the note where you are having a doubt. Okay, right. Okay, let's move into the topic, right? So, okay. The topic is relative motion. Relative motion, right? So motion we have studied, like the object is moving from one point to another point, like changing its displacement. Changing its position, we'll say, right? Changing its position. Whereas what is the meaning of relative motion? What is the meaning of relative? Relative is nothing but I'm relating something with another objects. I'm relating object A with object B, or object A with object C, or object B with object C. Okay, so by relating the motion of object A with object B is called as relative motion, we will say. I am relating the motion of particular object, okay, with some other object. Okay, right, that is the thing. So relative is nothing but I am relating an object with some other object. Relating an object with some other object. right? But motion is nothing but changes its position, na? Yeah, like when I talk about a motion, a object has been changes its position from one point to another point, right? Right. So relative motion. So let me consider object A or point A and object B. This object is going with some velocity 2 meter per second, and this object is going with 3 meter per second. Okay, like motion, no, like velocity, whatever, acceleration, displacement, everything, it comes under motion, like changes its position with respect to time, changes its velocity with respect to time, everything motion, right? So this is the thing we are discussing here. Everything will discuss under motion, like a position will discuss, displacement we will discuss, then velocity we will discuss, then acceleration also we will discuss. Okay, like everything have a same formula, like a similar formula. Okay, when I talk about a relative motion, I am talking about the position. Let me talk about here velocity of A and velocity of B. Okay, before going into the position, let me give a clear idea about that one. Okay, suppose I am talking about velocity of A with respect to B, okay, which is nothing but velocity of A minus velocity of B. Okay, whatever term is there first, I will write the term first minus the second term. Okay, then if I want to talk about, let me write the word here. Okay, this is velocity of A with respect to B. Okay, now if I talk about velocity of B with respect to A is nothing but velocity of B minus velocity of A. So this one how we will say, velocity of B with respect to A, right? Right now you can take a note of this. Done. Now we will go for the position. Okay, position. Suppose position of A with respect to B is nothing but RA minus RB. Position of B with respect to A is nothing but RB minus RA, where R is nothing but position vector. So I will write like this. R is nothing but position vector. Okay. Next we will talk about displacement. Displacement, right? So SAB is equals to SA minus SB. Then displacement of B with respect to A is nothing but displacement of B minus displacement of A. Okay, here S is nothing but displacement vector, right? Displacement vector. Wait a minute, I will arrange the camera. Sorry for the disturbance. I hope the clarity is clear now. Right now, the clarity is clear. Okay, yeah, you have taken down. Next one is the velocity. So velocity of A with respect to B is nothing but velocity of A minus velocity of B, right? Next, velocity of B with respect to A is nothing but velocity of B minus velocity of A. Done? So where V is the velocity. Next one, acceleration. So acceleration of A with respect to B is nothing but acceleration of A minus acceleration of B. Next, acceleration of B with respect to A is nothing but acceleration of B minus acceleration of A, right? So we have got the formulas for the relative velocity of position, displacement, velocity and acceleration, right? But we have talked about this as a vector, right? This as a vector. When we talk about a vector, vector has a both magnitude as well as the direction, right? Vector has both magnitude as well as direction. So direction in the sense, I need to note a point here, okay? Suppose object A is moving with some velocity in right direction, object V is moving with some velocity in the same direction. Let me take this as 5 meter per second and this is 10 meter per second, okay? Now what is the thing? Velocity of, so first thing, directions, no? So this is my positive, this is my negative, this is my positive, again this is my negative. The axis directions, okay? Axis direction only we will consider here also. So both are in positive direction. So positive and positive, let me write. So VAB is nothing but VA minus VB. So VBA is nothing but VB minus VA. Suppose object is approaching each other, A in this direction 10 meter per second, B in opposite direction of A, that is 5 meter per second. So this is my positive direction and this is my negative direction. So now for this case, velocity of A with respect to B is nothing but the formula, first you write it, okay? VA minus, okay, minus is the formula, okay? VA positive direction, okay, positive, minus VB. So answer will be VA plus VB. So if you notice here, if I am going in the straight, like in the same direction, VA minus VB coming. So if I am coming in the like opposite direction, no. So VA plus VB. Now velocity of B with respect to A, how we will write? Minus VB, because it is in the negative direction. Minus, so VA is positive, so VA. So what I will write? Minus of VA plus VB. So VA, like velocity of A with respect to B is velocity of A plus velocity of B, whereas velocity of B with respect to A is like minus of velocity of A plus velocity of B, okay? So this is the direction you should take a note when you are doing the problems of relative motion. First one is important is formula, second one is important is direction. So based on these two conditions, if you solve the problems, it will be easy to get the answer for the given questions, okay? You can take a note of this. Done. Can we go for the next one? Okay. Now there is a two condition. Okay. So first condition is upstream and downstream. We'll say upstream, and second one is downstream. So upstream, okay, what is mean by upstream and what is mean by down the stream? Up the stream or down the stream, we will say. Okay, suppose let me take a river flowing here. Okay, a river is flowing in this direction. Okay, so this is a river, so going with some velocity Vr. Okay, Vr. The same thing I will take here also, a river with velocity Vr. Right? Now suppose the person is going along with the river is called as down the stream. Okay, if the person is going against the river is called as upstream. Okay, upstream and downstream. So this is the person coming in this direction. Okay, so velocity of man, right? And in this velocity of man with respect to what, like in the water, in the direction of river only. Okay, this is downstream. So this is the major difference between the upstream and downstream. I am going against the river is called upstream. I am coming in the same direction of the river is called down the stream. Okay, down the stream. So you can take a note of this 2 points, 2 important points. Yes, 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 like the same thing only. The formula also will be same, right? See, if this is positive, no, let me consider this is positive and this is negative. Okay. Now what will be the answer for the given question when I talk about velocity of river with respect to man? So velocity of river minus velocity of man in the direction of opposite. So minus of minus Vm. So this is the answer. So Vr plus Vm, velocity of river plus velocity of man. Now velocity of man with respect to river is nothing but velocity of man which is negative minus velocity of river. So I can write like this, minus of velocity of man plus velocity of river. This is the formula for the river and man problem in upstream, right? Now down the stream. So now this is positive, this also positive. So velocity of river with respect to man is nothing but velocity of river minus velocity of man. Now velocity of man with respect to river is nothing but velocity of man minus velocity of river. So these are the formulas. Done. Can we go for the next one? Yeah. Done. So next one is the important case. Okay, you should take a note of that. Okay, like it's important thing when you try to identify the application. No, it is easy to find the answer for the given questions. Okay, so that is river and man problem, the shortest distance and shortest time to cross the river. Okay, that is the thing we are going to see now. I hope you have got this one right. Yeah, before that let me give a problem for this. Okay, we'll do a problem. So the question is, a man whose velocity in still water is 5 meter per second, right? So 5 meter per second. Then he swims from a point A to B, that is 100 meter down the stream. 100 meter down the stream. 100 meter down the stream. Okay, and back to A. Like he is swimming from point A to point B, again he is going to point A. Okay, now so velocity of a river is 3 meter per second. So first thing what he is doing along with the river, second thing what he is doing against the river, right? So velocity of a river is 3 meter per second. Find the time taken for the man, okay, for going upstream as well as the downstream. It's like both the streams they are asking. Okay, so the average speed of a man during the motion is, so they are asking what is the average speed of the man during the motion also. Okay, guys, wait a minute, let me arrange the camera, sorry for the disturbance. I guess it's clear now, right? Okay, so let's do. Now I need to find the time, right? Time is the thing I need to find. Now let me find the velocity for upstream and downstream. So this is man's velocity of man. Okay, velocity of river is 3 meter per second. Okay, sorry, this is velocity of river. Right? So upstream and downstream I need to get it. So velocity of a river with respect to man will be equals to, so one will be like opposite direction, one will be in the same direction, right? So 5 plus 3, 1 will come. Velocity of a man with respect to river, one more thing is 5 minus 3 will come, no? That's it. So 1 is 8 and 1 is 2. So total velocity is 8 plus 2, 10. And how much distance it has been covered? 100 plus 100. Down the stream 100, upstream 100. Right? Down the stream 100 and upstream 100. Yes. You need to calculate how much time it has been taken for downstream separately. You need to calculate the how much time taken for upstream separately. Think correct now? Yes. So down the stream 8, right, and upstream 2. So this is down and this is up. So time is nothing but displacement by velocity. So what is the displacement? 100. What is the time? 8. So this is 4 times and this is 50 and obviously 2 and this is 25. 12.5 seconds is taken to complete in the direction of Yes, down the stream. Now upstream. Upstream. Obviously it will take more time, na? Obviously it will take more time. So that is time is equals to 100 by 2, which is nothing but 50 seconds. Got it? 50 seconds. So this is the answer for the given question. Okay? You can take a note of this. Can we go for the next one? Okay, someone is asking. Puzzle. Okay. Okay, thank you. We'll go for the next one. So, river and man problem. So in this, two things we are going to find. First one is shortest distance. Second one is shortest time. These are the two things we are going to find. Okay, before that I'll give a glance over what is the thing we are going to see. So suppose, see, listen carefully. So suppose now the river is flowing in this direction. Okay, river is flowing in this direction. Now what happened? I am trying to cross the river from point A to point B. This is my point A and this is my point B. A and this is B. So if I start like this, if river is not flowing, I can walk like this. I can cross in the straight manner. But someone is pushing like this. So if I am walking in this direction, someone is pushing, no, I will be going somewhere like this, right now, somewhere to point C. Let me take point C, because river is flowing like this. Suppose the thing is normal water is there, I can cross easily like this. Now river is flowing. If I start like this, I will go like this, or if I start like this, I will come in this manner, right? Okay, keep it simple now. So this is the position I will reach if I start like this. So some angle has been made, that is theta will keep. This one is clear now. Now think that, hurry, wait. Yeah, now the camera is clear, no? Fine. So think that three persons are there. Person A, person 1, 2, 3. Let me consider person 1, 2 and 3. Two persons are going in boat and one person is on the ground. So person 3 will be here, person 1 and 2 started like this. So for person 1 and 2, what they will think? Like velocity of boat with respect to water. Yes, no? Like I am traveling in the boat. What I will think? I will go in the straight, I am going in the straight manner, right? But when the person is standing back beside me and watching, what he will think? Like he is thinking that I am going somewhere like this, like in some angle, right? Now this is the velocity of boat with respect to river. Got it na? Now this is the velocity of boat with respect to ground, and this is my velocity of river with respect to ground. Now how many things we are going to see here is, velocity of boat with respect to river, velocity of boat with respect to river or water. Next one is velocity of river with respect to ground, velocity of river with respect to ground. Next one is velocity of boat with respect to ground. Right? So these are the three things, three important things which we are going to see here. Okay? Now you got it, na? I will explain once again the thing. Okay? Point A, B, C is the condition. Like I am starting here, river is flowing. If I want to start from ear to ear, like I want to cross this river exactly in the opposite side, but due to river flow, I am crossing and I am like landing at point C. Okay. Now I am taking an example, person 1, 2, 3. 1 and 2 are going in a boat and 3 is watching from here. So 3 is watching from here and 1 and 2 are going in the boat. So for 1 and 2, no, 1 and 2. So 2 is watching 1, he is going in a straight line. 1 is watching 2, he is going in a straight line. Yes, na? For boat, they are thinking that I am going in a straight river, in straight manner only. But what person 3 is seeing when he started, but he is going in this manner. Like this is the velocity of boat with respect to ground. This is the velocity of a boat with respect to water. This is the velocity of a river with respect to ground. Okay, clear? So this is the case. So this is the glance about river and man problem. So you can take a note of this. Next we will see the shortest distance and shortest time conditions. Okay. Done? Okay. Now, shortest distance. So, the conditions we have seen, right? Now, the thing, if I start from here point A, I need to reach point B, but instead of I am reaching point C. So, which is the shortest path to cross the river from one end to another end? So, point A to B is the shortest thing. But if I start from point A in the direction of B, I am ending at C. So, what should I do? So, I should do some magic. I should do some magic to stop the river, like the Krishna did, no? Like when Krishna born, so Krishna's father took Krishna, and when walking in the water has been separated like in a two direction, no? Like that? No. I should use some physics over here. Okay, right now I should use some physics over here. Hurry, wait a minute. Again, camera gone. Sorry for the disturbance again and again. I guess due to this brightness, it's getting blur. like I have on one more extra light. Okay, so like what Krishna did, no, we can't do like that. We are human beings, na? Okay, now we should use physics only, right? We should use physics. So I should start with some angle. If I start like this, no, I will reach like this. If I start in this manner, I will reach in this manner. So river is flowing in this direction. So velocity, same. Whatever you are taken in the previous slide, the same variables only we are using here. So velocity of river with respect to ground. This is velocity of boat with respect to river, velocity of boat with respect to ground. That's it. So this is my angle theta. So now what we should do? I should take the trigonometric ratios. That's it. Completed everything. So sin theta will be equals to opposite by hypotenuse, velocity of a river with respect to ground divided by velocity of a boat with respect to river. This is my hypotenuse, na? Yes. So cos theta will be equals to velocity of a boat with respect to ground divided by velocity of a boat with respect to river. Next one is tan theta. Tan theta will be equals to velocity of opposite by hypotenuse. So adjacent, na? Opposite by adjacent. Velocity of a river with respect to ground divided by velocity of a boat with respect to ground. So these are the things. If you complete this one, problems has been completed. So suppose person is asking what is the velocity of the given condition, like to cross the shortest distance. So this is my velocity of boat with respect to ground. I no need to take this velocity of a boat with respect to river. By using this one I got this one. No, like these are the conditions, but which velocity I am using to cross the river in shortest distance? This is the shortest distance, right? So okay, take a note of this. Okay. Okay. So here up to this, so we'll stop today's class now. Okay. So we'll continue with the shortest time and the problems in the upcoming classes. Thank you guys. We'll meet in the next class. Okay. Bye bye.